Welcome to The Explainer. Today, we're diving into something that is quite literally flipping the script on science education. We're talking about the misty state revolution. Look, if you've ever tried to wrap your head around quantum mechanics and thought, nope, I am never going to understand this, you are absolutely not alone. For decades, the barrier to entry has just been incredibly high. But we're going to explore a fascinating 2026 paper by Dan Adrian German titled A Term-Rewriting Semantics for Pure Quantum States, and it outlines a method that completely transforms how we introduce these mind-bending concepts to first-time learners.
So, can middle schoolers really calculate quantum circuits? I mean, no way, right? It sounds totally impossible. When we hear quantum circuits, most of us immediately picture massive chalkboards covered in advanced linear algebra, complex numbers, and just terrifying equations. We definitely don't picture 12-year-olds casually solving for quantum entanglement. But the truth is, we are going to look at a framework designed to make exact real quantum calculations accessible to beginners, including kids. It's a system that takes the core foundational behavior of quantum mechanics and distills it down into a language that simply doesn't require a university degree to speak.
Section 1, the quantum math problem, and overcoming that massive barrier to entry.
To really grasp why this is such a game changer, we have to talk about the brick wall most students hit. Conventional quantum math requires you to absorb massive amounts of complex mathematics before you're even allowed to touch the actual physics. It's exhausting. Students get so bogged down in the heavy mathematical apparatus that they completely lose sight of the fascinating quantum phenomena that are actually happening. But the Misty State approach, it's completely different. It uses something called term rewriting and relies purely on simple arithmetic. It essentially bypasses that entire wall of prerequisite math and gets straight to the heart of the matter. It makes it totally, genuinely accessible even to middle schoolers.
Moving to Section 2, the Misty State solution, which actually traces back to Terry Rudolph's breakthrough in 2017.
So what exactly is a Misty State, anyway? Well, it's an elementary rewriting system that represents pure quantum states to accurately describe quantum circuits and computation. Okay, what does that mean in plain English? Basically, instead of using intense multi-dimensional geometry and advanced calculus, you represent quantum states using a set of basic rules. It's kind of like a specialized grammar. You literally just rewrite terms based on these rules. It's a representation that lets you calculate the basics of quantum theory without needing a PhD. Think of it like learning the rules of a board game. Once you know how the pieces are allowed to move, you can play the game, right? You don't need to understand the complex physics of how the cardboard was manufactured.
And this isn't just some cute toy model. It is rooted in deep, rigorous science, and it works in 3 clever steps. First, it leverages some really powerful, established mathematical results by researchers Yaoyun Shi and A.A. Kitaev. Next, it takes that heavy math and shrinks it down into a tiny, universal set of gates. You can think of these gates as the absolute minimum number of building blocks you'd need to construct any quantum circuit. And finally, because these gates are so carefully chosen, you can execute the actual calculations using nothing but simple arithmetic. I'm talking adding, subtracting, multiplying, and dividing. You're doing real quantum computation with grade school math. It's wild.
Which brings us to Section 3, upgrading the formalism, focusing on Dan Adrian German's 2026 extension.
German's 2026 paper really takes this educational tool and aggressively pushes its boundaries. He starts off by reviewing Rudolph's original 2017 proposal, just to set the stage, but then, and this is the cool part, he demonstrates the system in action via entanglement swapping. Now, entanglement swapping is a highly non-trivial quantum protocol. It's literally the backbone of future quantum internet concepts. To prove that you can map that out using simple arithmetic is just amazing. He also introduces some new concepts like irreducible misty states, which act as fixed points. Think of them as completely solved puzzle states that you just can't break down any further. He even presents the famous GHZ game, which is a classic thought experiment in quantum mechanics, entirely within this new representational semantics. He's proving that the seemingly simple tool can handle some really heavy lifting. And that gives us this massive takeaway. This system is universally applicable. Every calculation can be done to good enough accuracy with only a small overhead. German makes it very clear that you can perform any quantum calculation accurately using just these simple rules. You aren't sacrificing the core truth of the physics just for the sake of simplicity. Sure, there might be a slight computational overhead, meaning, it might take you a few more steps on a piece of paper, but the exact accuracy is absolutely there. You are doing real physics.
Section 4, a bridge to conventional math, or as I like to call it, training wheels for quantum theory.
Now, you might be wondering,
Is this meant to replace traditional physics education forever? Not at all. German is incredibly practical about this. He writes that the Misty State picture is, quote, a good way of getting people to the heart of some non-trivial quantum theory without having to first absorb a huge amount of what might initially seem largely irrelevant math. So nobody is advocating that professional theoretical physicists just throw away their advanced calculus and linear algebra. Instead, Misty States are the ultimate set of quantum training wheels. They're a pedagogical tool designed to capture a student's curiosity by letting them do the cool stuff right out of the gate.
Ultimately, the MISTY formalism facilitates a transition to the full conventional quantum mathematical apparatus. It acts as an essential bridge. Think about how we teach kids to ride a bike. We don't stick them on a high-performance racing motorcycle on day one. We give them a little bicycle with training wheels so they can feel the concepts of balance, steering, and momentum. And once they have that core conceptual understanding, taking off the training wheels and learning the harder mechanics becomes so much easier. German's paper proves that Misty States give students that exact deep conceptual understanding they need before they have to take on the heavier equations.
Which leaves us with a truly thrilling, provocative thought to wrap up today's explainer. If quantum mechanics is just simple arithmetic away, what else could we be teaching our kids? If a subject that is widely considered the absolute pinnacle of complex, unapproachable science can be translated into a system that middle schoolers can grasp, it forces us to completely rethink STEM education. Are other impossible subjects out there merely suffering from a bad translation? What else just needs its own Misty State to unlock a whole new generation of young scientists? Thanks for joining me for this explainer. I hope you never look at quantum physics or how we learn it the exact same way again.